Today we'll study about the virtual circuit. Earlier we have studied circuit switching and one approach of packet switching, that was datagram. In circuit switching we have seen that a dedicated path is used from source to destination, and until and unless the data transfer is not completed, the path will be there. And in between, if data transfer is not being taken place, then also the dedicated path will be there between source and destination. In case of datagram, we have seen that it will break up the entire data set into some small packets, and it will transfer those packets in different ways through the switches from source to destination. In case of virtual circuit, what happens? It is the combination of both circuit switching and datagram. That means a dedicated path is used, but it transfers the packets from source to destination. So let's see some points about this virtual circuit. As you can see that some points are written here. A virtual circuit network is a cross between a circuit switched network and a datagram network. So already I have mentioned that one, that this virtual circuit network, it is a combination of both circuit switching and datagram. The characteristics of virtual circuit are here. Actually it has three different phases. One is setup phase, another is data transfer phase, another is tear down phase. Now in setup phase, what happens? The source and destination use their global addresses to help switches to make table entries for the connection. Actually, whatever the switches are there in between source and destination, each of them, they maintain a table, and in that table they enters the required information of all the packets which are being transferred from source to destination. So once this way the path is established between source and destination through several switches, then the second phase starts, and in second phase, using the same path, all the packets get transferred from source to destination. Earlier, in case of datagram, we have seen that packets may travel through different routes, but here, as the dedicated path has been established, using that path, all the packets will be transferred from source to destination. Now the thing is, when this path will be established, one switch will try to find out the nearest available switch to forward the data packet, and this process will go on, and this way the path will be established from source to destination. Once the dedicated path is established, then actually data transfer takes place. And the last phase, what is that? That is tear down phase. In tear down phase, what happens? All the data packets, all the data packets have been transferred to the destination. So here the source and destination inform the switches to delete the corresponding entry. So no more data packets are there to be transferred. Therefore, source and destination, they inform the switches through which the dedicated path was established to delete the corresponding entry. Let's see a sample of virtual circuit. Say this is the endpoints, means say it may be a source, it may be the destination. In between, different switches are there. So when this source wants to send some data packets to this destination B, then what will happen? First the path will be established. Say this switch is available, so it will be included in the path. Now this switch will try to find out the nearest switch to forward the packet. Say this one is available, so it will be included in the path, and this switch will try to find out the next nearest switch to forward the packet. So this switch is available, so it will be included in the path, as well as this switch also will be included in the path, and this switch will connect the destination. So this way the dedicated line or dedicated connection has been established. Now this source will start sending the packets from here to here, and through these switches these packets will be transferred. That means all the packets will move forward from this switch to this switch, this switch to this switch, and this switch to this switch. So in proper order they will be transferred to the destination. So this way a virtual circuit works. Now the thing is, in virtual circuit switching, all packets belonging to the same source and destination travel the same path, but the packets may arrive at the destination with a different delays if resource allocation is on demand. So what does it mean? Actually, when the dedicated path will be established, that time these switches, they will try to find out the nearest available switch to forward the data packets. So maybe say for transferring some data packets, these switches may not be available because they may be busy for transferring some other data. So it may take a certain time to establish the path. Next time when some other data packets will be sent, say the switches are available, so very easily, very quickly the path will be established. So it may vary. So different types of delays may be there. Now let's try to understand the delays in case of datagram. Say this is the source and this is the destination. In case of datagram, what we know, source will transfer the data packets one by one. Say this is the source and it has transferred a data packet to this switch. Now this switch will try to find out the nearest available switch. So it will take some time, and say this is the delay. After some time, this switch has got another switch which is available, so it will forward the packet. So the data packet will be here. Then it will try to find out the next point. So it may take some time. Say this is the delay here, and after that, when it will establish that connection, then the data packet will be transferred to the destination. So here you can see that here the waiting time is something and here the waiting time is something. That means from one point to another point to transfer data, it may take different waiting time in case of datagram. But what happens in case of virtual circuit? Let's see that. So in case of virtual circuit, what happens? Say this is the source and this is the destination. Now first the dedicated path will be established. So using these switches, say the dedicated path has been established, and when the connection between source and destination using the dedicated path has been established, then data transfer will take place, and you see here the waiting time is 0. That means as the dedicated path is being used, so it is informed already that through which way the packets will be transferred. It's not like that that after reaching to one point, that point will find out the next available point. So here already the dedicated path has been established, and using that path the data packets are being transferred. Therefore after establishment of that path, data transfer will take place and there will be no waiting time. So I hope how does a virtual circuit work, that is clear to you. Okay.